All right, with this, we are ready for our next talk. And for this talk, I'd like to bring on Mike from Duoro Labs to tell you about all the things that we can do to make DeFi a lot better. So please give Mike a big round of applause.
Let's talk about making DeFi better. And we'll start off with slide number 1, which is how I make friends at a crypto conference. So DeFi sucks, obviously. We're all here building in DeFi, so we need to put some in context around that. So DeFi sucks when we compare it to the boss being TradFi. We're obviously trying to build new financial rails. Now, there's obviously problems with TradFi or CeFi. Think about trying to move a country. Onboarding is pretty terrible. Sending money always has fees. Getting a decent interest rate is all very difficult. But when it comes to a lot of stuff that doesn't involve the once every couple months thing that really bothers people, it's pretty good. Robinhood, Charles Schwab, NASDAQ, these are indicative of what I'm talking about. You basically have super, super low commissions, $0 commissions on Robinhood and on Schwab. Round trip times are incredibly fast, 500 milliseconds or less for retail trading, about 300 milliseconds or less for small institutional trading, and if you're trading as a large institution in a data center for one of the top tier exchanges, we're looking at sub 1 millisecond. And trust obviously is trusting the brands. So if they screw up, well, you can sue them. So there's no programmatic trust, but they're not rugging you all the time. They are obviously exploiting trust in certain ways, such as putting in some of these fees. Now your average DeFi app is pretty bad relative to those 3 categories. For the most part, the fees are going to be nowhere near a sustainable 0 commissions that you would get on some of these trading apps. Your time for round trips is usually around 2 seconds or more on most blockchains. And the trust, for the most part, for applications is relatively centralized and doesn't have the brand around it. So there's no really someone you can go out. We all have heard about rugs. Now, Pyth makes things a little bit better. We're going to get into some of these topics today about these 3 categories and how it helps improve them. But we start to make progress towards TradFi. So what's competing DeFi from competing with TradFi? The sad reality of new technology is that there's the thing that the new technology is famous for, which is going to be kind of security and this new form of trust. And then there's everything else, which is the incumbent. And the reality is that the people that really care about that thing move on very early, and they all are very frustrated with how long it takes everyone to come on. The problem is everyone only comes on when the other elements are at parity with the incumbent. Now we'll go through an example to show how this actually works. So if you go back to the 90s, you had Amazon as your first kind of online shopping. It was competing against the Sears catalog at the time. Right? Sears catalog was like the Amazon of its day and had been around for like over 100 years. You turn a page and you can load 10 images in about a second, right? You turn a page, there's 10 pictures there. On Amazon, using a 56K dial-up modem, it would take you about 2.5 minutes to download 10 images. So obviously, it's not nearly as good as the competitor. Here we are. I'll go through this. Not nearly as good as the competitor. And so all of the things that you do when you start talking to somebody who doesn't necessarily understand the benefits of being connected to the store, getting the inventory updated in real time, not having to go through another means of execution using a phone or doing a mail order to get access to something, they don't understand any of this because all they see is that Sears catalog is going to be so much faster. Now you cut to 10 years later and you get 100x improvement on the speed. You can start to download pictures at about 1 second, 10 pictures. And this is when things start getting interesting. And people don't generally know about what's going on in the back end, but it's because infrastructure keeps improving. So we went from 56K dial-up modems. 10 years later, we started to get broadband. Those lines were just getting laid down, so not everyone had them all at once. And then we got fiber, and we started moving into mobile technologies and 5G. Now you can go on your phone, and if you go to Net-a-Porter, you can look at real streaming video or real live video without any load times, and it feels very seamless. And the things that people who don't necessarily know about the technology say is just it feels better, right? It's that innate ability to notice that there's no friction, or it doesn't feel like it's a janky trade-off. Now, on blockchains, as I mentioned, the big innovation that I'm sure that we're all excited about is trust, right? So pre-web, trust was person-to-person, very inscalable. You can only interact with people that you knew or you can interface with. With the web, you can now interact or communicate with anyone around the world. But it was difficult to have trust. Everyone's heard the story about buying an Xbox on eBay and getting a box full of rocks. So you have all kinds of problems with trust on the web. Web 3.0, crypto gives you the can't be evil rather than don't be evil, and we have that programmatic trust. So if I use that same parallel to compare DeFi to its incumbent, let's say Charles Schwab is 300 milliseconds round trip time and it's $0 commissions payment for order flow. Let's see how DeFi has come in terms of users and adoption through the lens of infrastructure. So 2020 is DeFi summer, and you had 12-second blocks, about 12 TPS. Push oracles at that time updated every 24 hours or 50 basis points. And so you'd basically have to take the worst of when the oracle price had updated or the block time. You can't do a whole lot of computation with the limited space, and so we ended up getting DeFi 1.0 apps, which were delightfully retro and cool, had great trade-offs, to make them work, but they weren't what you'd expect to beat Robinhood, like the AMMs from Generation 1 or lending protocols. Those were really experimentations for people that really wanted to get dirty on decentralization. Then a year later, Solana came out and really changed the operating system from 12 seconds all the way down to 300 milliseconds. This gave us a whole lot more expressivity with writing smart contracts. Applications. We saw for the very first time derivative trading platforms on chain. We saw some order books on chain as well. Behind the scenes, you're getting Pyth prices that were updating at every Solana block. You synchronized block updates with Oracle updates at 400 milliseconds, which is quite fast. And then in 2023, I think the rest of the world realized that rather than convincing people that performance wasn't important as decentralization and performance had to improve. And so we saw EVM take on the same performance. It got up to around 2 seconds on, like, say, the super chains on some of the L2s, but some of them are actually a little bit lower. So we saw that sort of Solana-style speeds everywhere. The Pyth Network is designed to supercharge DeFi infrastructure so that dApps can compete with apps. And it does so across 3 different verticals. And these are the ones that we kind of compared on the first metrics. So there's trust, speed, and cost. Currently, there are 3 product lines within the Pyth Network, which we'll go through now. So the first one is probably the most well-known. It's price feeds. So the Oracle problem for blockchains is very well understood. You've got a blockchain that has programmatic trust built into it. There's either proof of work or proof of stake, and there's validators that are maintaining that stake with high levels of trust. Now, as soon as you bring in something exogenous from the state, you have to come in from a trusted source, or you've broken that trust completely, right? And that's effectively the Oracle problem. Now, the first generation of solving that Oracle problem was all around building trust, but didn't think of this from speed, and that was what I showed you initially. To solve that Oracle problem at speed, you need to understand some of the mechanics of how market data works. So the market data industry for financial products is very well developed. It's about a $7 billion a year business. There's about 6 large exchanges that make the majority of that money. That data is all most valuable at a time of 0 because after about 15 minutes you can get the data for free. So there's a very fast decay on it. The closer you can get that data to time of 0 to put onto the chain, the much more valuable it is. Now, the business model that large exchanges have for selling their data is incompatible with blockchains. They sell via subscriptions. Every user has their own subscription. It's limited to the number of users that they have. And a blockchain breaks this because it's a shared state, which means that it could only ever be one subscription. Not only that, these large institutions, large exchanges have no incentive to see blockchains grow. They have no interest in it. And so the first problem with getting this data on chain is where you're going to find the sources from it. So the Pyth Network innovated this by going to large holders of data that have never participated in the market data economy before, and that was large trading firms. So if you think about the way that the financial markets work in traditional markets, there's your average user or trader, and then behind the scenes, there's really large trading firms, Jane Street, Susquehanna, DRW, Jump Trading. And these firms generally take on a tremendous amount of the volume that gets executed on different asset classes. They are only on the buying side of market data. They actually have to buy that market data back, and it's something that's bothered them for a long time. So the innovation number one for the network was go get data from them. They're never monetizing it. It'd be the first time for them to monetize their data, and they've got troves of it. Put it together, and you'll be able to stitch together a very, very comprehensive view of all markets with a cost basis of effectively zero, because they're not comparing it against opportunity costs of selling market data elsewhere. And that's how Pyth creates its price. There's over 100 institutions, large institutions, including all the large crypto trade exchanges like Binance, all the way down to the smaller ones. There's traditional exchanges, like US equity exchanges like MIEX, IEX, MEMEX, and Cboe Global Markets, which has the VIX. And they're contributing data all in real time to a place called PythNet, which is a public blockchain. It gets aggregated with full transparency, and from PythNet, it's then made available to be pulled onto 80 different blockchains. And this is where the economics starts to work. So as I mentioned, economics for pushing onto a singular blockchain is broken because then it's available to everyone. Nothing gets passed back to the data owners. By having everything put onto a singular application chain called PythNet, and then having each one, when it's being used or called, paid for, it creates this model. So every time there's an application that needs a price on Ethereum, Optimism, Arbitrum, Solana, they pull that price directly from PythNet, and then they pay a small fee. And those economics are able to get passed back to the owners. And there's been two iterations of Pyth so far, price feeds. So the first one was pushed onto Solana, and then the second one was the migration over to PythNet. Solana obviously was only available to Solana, and now it's on, as I mentioned, 80 different blockchains. There's currently about 400 users, application users of Pyth price feeds. You can see what we get out of that from those three categories. So number one, the trust, as I mentioned, is a public blockchain. It's all verifiable. There's 110, actually, different data sources who are validating the chain as well. The cost is very cheap because, as I mentioned, we're sourcing this from brand new data sources. We're not sourcing it from somebody who's looking to extract billions of dollars for the cost of it. And it's fast. 400 milliseconds is pretty close to the 300 milliseconds that we were talking about from Schwab. The second product line for the network is on-chain randomness, so this is called Entropy. And this has a very similar problem set to that of price feeds. It's an Oracle problem. So if you're running a game of chance, how does somebody know that this has not been manipulated? How do I know that there's trust that's been built into this? And Entropy does this with a commit reveal mechanism. This is an old cryptographic technology that's been around for a long time. Two parties effectively commit secrets, and then they hash those secrets, and those hashes then get revealed, and then the end result is hashed on chain. So that allows applications to show to their users that this has been done by a program that cannot be manipulated. From here, it's very costly, about 5 seconds per update for Entropy, and it's quite fast. It's around 400 milliseconds response. All right, and the third product for the network is called Express Relay. So Express Relay focuses on this MEV problem. So maximum extractable value or minor extractable value is basically the term for all the revenue that gets leaked out from a protocol to validators or miners. And when you think about the best example being a liquidation that would happen on a lending protocol, generally what happens is the validators will either reorder the block so that it's more favorable to them, or they'll create an auction where they're getting the ability to put something in first, and then they're keeping the proceeds of it. Express Relay is different. So Express Relay is a new primitive that connects protocols directly with an established set of searchers. And it allows them to run the auction themselves and then be able to keep the majority of the proceeds. That's number one. So a lot of these costs get not leaked out to validators, but maintained within the application protocol itself, and can be passed on to users as well. So this gets us down to some of the lower fees charging, similar to what we've seen in TradFi. Yeah. So here we are. This other element of it that you can think about from a speed perspective is kind of time to market. So if you can plug into this established set of searchers, one of the big problems that a new protocol will have is, I have liquidations, but I need somebody to be monitoring it so that when the liquidation is triggered, there's somebody to go and execute it. New protocols actually struggle with this quite a bit. An established set of searchers gives you the ability to plug into that day one and have liquidators who are watching for opportunities right away. So kind of time to market is the way I would think about speed as being the fastest here. And then obviously on the cost side, those get passed on and not leaked out. So there's a large number of applications that are using Pyth products already today. As I mentioned, there's over 410 on 80 different blockchains. Actually, 60% of derivatives protocols on any blockchain are using Pyth, according to DeFi Llama, and so that's about 100 applications. In fact, it accounts for more derivatives trading that has been enabled on blockchains than any other single protocol, blockchain, or Oracle, and that number has grown by about 10x in the last year. And you can see the growth and the market share that on-chain derivatives are currently eating up against Binance. And that's it. That's the main point of the network, is to make sure that there is a possibility to keep making infrastructure better so that these applications compete not just on decentralization, compete on portability, compete on those things that make somebody wonder, isn't there a better system? But it makes it so that everything is better, as well as all those elements. And the Pyth network won't stop improving until we've beaten TradFi on all the other metrics. Cool, thanks so much.